Alright, in this section we're talking about linear functions. The first thing I'm going to do is define what a linear function is. A function whose graph forms a straight line is called a linear function. So if you look in this picture right here, I have a picture of a linear function. It forms a straight line. Looking onward, what we're going to be doing is doing a few examples where we're deciding whether or not, first of all, if it's a function, and then whether or not it is a linear function. So in this first picture, what I'm going to do is test it with the vertical line test. The vertical line test says that as long as each vertical line only passes through the graph in exactly one spot, it is considered to be a function. Notice how these vertical lines only pass through the graph in exactly one point. So I will write that yes, this is a function. Now, because it's a function, I will go ahead and answer the second question. Is it a linear function? And the answer to this is yes. And the reason for that is because it forms a straight line. So it is a straight line. My second example looks like this. And the first thing I'm going to ask again is whether or not it is a function. So if I start drawing my vertical line, notice how it passes the vertical line test. Each vertical line only goes to the graph in exactly one spot. So yes, it is a function. But the second question is no. No, it's not a linear function because it does not form a straight line. There is no straight line. My third example, does the graph represent a function? Well, I will test it with the vertical line test. Notice how when I draw this vertical line, all the x values are exactly the same, so it does not pass the vertical line test. This is not a function. Because it's not a function, we're not going to answer the second question. The second question says, is the function linear? Because it's not a function, we're not going to answer whether or not it's linear. The next question, or the next example, I should say, I start drawing my vertical lines, and notice it is a function. Each vertical line passes through the graph in exactly one spot. So yes, this is a function. Second part, is the function linear? Yes, it is linear. It makes a straight line. There is a straight line. My last example says, is this a function? Again, one more time, I'm going to do the vertical line test. Notice this time, though, this is not a function. Each of these vertical lines pass through the graph in 2 points. So this is not a function. And because it's not a function, I won't even answer whether or not it's a linear function. You can also tell, not only from a graph, whether or not something's linear, you can tell by looking at a table or a list of ordered pairs. So this example I've given you is considered to be a linear function because there is a constant change in x that corresponds to a constant change in y. So what are those constant changes? Well, in this one, the constant change on the x is a positive 1, where the constant change in y is a negative 3. Now, I will mention that you do not, or these values will not necessarily match up. The constant change in y can, or the constant change in x can be different than the constant change in y. Let's go and see if we can get through an example here. So tell whether the set of ordered pairs satisfies a linear function. So what I'm going to do is look at the constant change in the x's. Notice I'm drawing arrows to each of my x values, and I'm going to see if there's a constant change. So 0 plus what gives me 4? Well, plus 4. 4 plus what gives me 8? Plus 4. 8 plus what gives me 12? Plus 4. And I check it all the way through. There is a constant change in x. Now I'm going to look for that constant change in y. So I'm using a different color, and I'm drawing to all the y's. Negative 3 plus what is 0? That's 3. I'm going to run out of time, so I'll finish this in the next video.